Good evening, everyone. So welcome to my YouTube channel, Avatarm. So today we are going to see how to sum first and terms in a GP. Okay. So still, if you have not subscribed my YouTube channel for such type of interesting topics, subscribe it immediately. So let's start today's topic now. Okay. Okay. Suppose a GP is given AR square. Okay. Nth term is an minus AR to the A into R to the power n and so on. Okay, this is GP. Okay, first term is A and nth term is common ratio is R. Common ratio is equal to R. Okay, so we are to sum first n terms. Okay, we are to sum first n terms of GP. Let's say it's star. GP star. Okay, we let S is equal to, we are taking sum Sn. A plus AR plus AR square. Okay. AR n minus 3 plus AR n minus 2 plus AR to the power n minus 1. So let's say it is equation number 1. Okay. So multiplying by R in 1, we get R into Sn A plus AR plus AR square. We are multiplying by R. Okay. So R into Sn AR plus AR square. Okay. AR की cube AR n minus 2 plus AR n minus 1 plus AR to the power n. Okay. Okay. Subtracting 2 from 1, we get. Okay. What we get? Because AR will be cancelled out. Sn minus R Sn. So AR will be cancelled out. AR square will be cancelled out. And AR n minus will be also cancelled out. So what will be? First term A will be remain and we are taking minus. This will be remain. This will be remain. All the terms will be cancelled out. Okay. So let me write properly. Okay. So A plus AR square AR to the power n minus 3 AR to the power n minus 2 plus AR to the power n minus 1 minus AR plus AR square plus ARQ, ARn minus 2 plus ARn minus 1 plus AR to the power n. Okay. So this term will be cancel out this. This term will cancel out this. There will be R3 that will also cancel out this. This will be cancel out from somewhere here. So this will be cancel out this and this will be cancel out. So what is this? This implies you take R Sn common 1 minus R and this is A minus AR to the power n. So you can take A common. Okay. So this implies Sn is equal to A upon A1 minus R to the power n upon 1 minus R. Okay. So the sum of first n terms of GP is given by Sn is equal to A1 minus R to the power n upon 1 minus R, this formula. Okay. This formula. Now suppose if R modulus R is less than 1, then what will be R tending to R to the power n will tends to 0 as n tending to infinity. Then as infinity will be equal to A1 minus 0 upon 1 minus R. This will be S infinity is equal to A upon 1 minus R. Okay. If a GP has infinite number of terms with a common ratio less than whose modulus is less than 1, then sum of all the terms of this GP is given by F infinity is equal to A upon 1 minus R. Okay. So we know that how to calculate sum of first n terms of GP, that is Sn is equal to A into 1 minus R to the power n upon 1 minus R. But once a series is infinite, once a GP is infinite and whose common ratio's modulus is strictly less than 1, then the sum of all the terms of all the infinite terms of this GP is S infinity is A upon 1 minus R. The sum is given by S infinity is equal to A upon R. Okay. So this is not 1. I am saying it's not. Sorry. Let's say it's not 1. You write not 1. Observation 1. Okay. 1. So observation 1 is this. Now, observation 2. Suppose this GP is given AR square. Okay. And L. Okay. L is last term. Okay. L is, this is finite GP, okay. This is finite GP. L is last term of this finite GP, okay. Finite GP. Then suppose there are, so we have this AR square. Suppose there are, this GP has n terms. If this GP has n terms, what will be the last term? Last term will be L is nth term. L is equal to nth term. And n term formula is given a into 1 minus, so L is equal to a r to the power n minus 1. Now, what is the formula of, because this GP is finite, so it has n number of terms. So what is the formula of first n term? Because once series is given infinite, and it, how to find sum of first n term? Sn is equal to a into 1 minus r to the power upon 1 minus r. But here itself is given the series GP is finite, it contains n terms. Directly we can find the sum of all the term Sn equal to a into 1 minus to the power r to the power n upon 1 minus r. Okay. So what is Sn? Sn is equal to a 1 minus r to the power n upon 1 minus r. But I want to skip the n here. Okay. So I want to skip the n, because I know that n terms is given. So there is no, we are taking sum of all the terms. Okay. So S is, but this is Sn. Okay. So I can take a inside. So how can I write this? A into a r to the power n minus 1 upon 1 minus r. So what is a? What is a? This is a r to the power n is nothing but L. So S is equal to a, you can take common 1 minus L upon 1 minus r. So if a finite GP is given and last term is given, first term is given, and common ratio you know, then you can find the sum of all the terms of that finite GP. Okay. Okay. So this formula is applicable once you have a finite series. Last term is known, and you have first term and you have common ratio. So let's see examples. It will be clear by examples. What is the sum of first and first 10 terms of the given GP? Okay. So you can ask for eight terms. What is the sum of first 8 terms of this GP? You can ask 8 or 10 solution. So what is GP? GP is given 3, 6, 12, and so on. Solution is 3, 6, 12. This is GP. Okay. So what is the first term? A. What is the R? And they show 6 by 3. That is 2. Okay. Because this is infinite GP is given, so so we will use Sn. So n is given 8. So what is Sn? formula a 1 minus r to the power n upon 1 minus r. So S8 is equal to what is a 3? 1 minus 2 to the power 8 upon 1 minus 2. Okay. Okay. Now tell me what is the answer? 3. Okay. So 2 to the power 8 means what? 256 upon this is minus 1. So what you will get? 3 into 255 upon minus 1. Minus minus will be cancelled out. So what is the S8? S8 is equal to 15 1. Carry is 1 1. Okay. This is the answer. Okay. So first sum of first 8 terms of this GT is 765. Next question is what is the sum of the given GP? Under root 2 1 upon under root 2 1 upon 2 under root 2 1 upon 4 under root 2 1 upon 5 1 2 under root. You see that in this what is this is GP. So under root 2 1 upon under root 2 1 upon 2 under root 2 1 upon 4 under root 2 1 upon 5 1 2 under root 2. This is finite GP. Finite GP. So what is L here? First of all, what is A here? A is under root 2. What is R? R is 1 upon under root 2 divided by under root 2. That is 1 upon 2. And what is last term? Last term is L is equal to 1 upon 5 1 2 under root. So what is the sum of all the terms of this GP? S is equal to 1 minute. I have made a mistake in calculating the formula of this. Let's correct it. Okay. If you see that here, I have, let me correct this. I can write this as a R into, okay. So this is LR. So this is L into R. Okay. So you have, what is the formula? Formula is that E minus LR. Okay. So this is the formula. Correct it. Okay. Sorry for that. Now come to this. So what is the formula to calculate the sum of finite GP? This is nothing but S is equal to A minus LR upon 1 minus r. Okay. So a is 1 upon, sorry, a is 1 under root 2, or L is 5, 1, 2 into under root 2. And what is r? 1 upon 2. Okay. So what is this? Under root 2 minus 256 under root 2 upon 1 upon. Okay. So 1 minute. Let me check. There is some problem. Let me check it again. Sorry, L is, sorry, I made a mistake actually. L is here, this one. This is, so let me write it. 1 upon 5, 1 to under root 2. So what is this? Okay. So what is this? This is 1024 under root 2. Okay. So after solving, what you will get? You will get, to take this under root 2 into 10,024 under root 2 minus 1 upon 24 under root 2 upon. So what you will get? 48 minus 1 upon 5, 1 under root. So what, after solving it, what you will get? 2047 upon. So this is the answer. Okay. Now we are seeing another example. What is the sum of given GP? Under root 2 1 upon under root 2 1 upon 2 under root 2. Now same series is given, but this is not finite. This is infinite series. Okay, this is infinite series. How to find the sum of this series? Solution. So what is A here? Under root 2. What is R? R is already calculated 1 upon 2. Because we are to calculate S infinity. What is R? First of all, see that R modulus of R is 1 by 2. That is strictly less than. So we can calculate the sum. What is A upon 1 minus R? So what is that? A is under root 2. R is 1 minus under root 2 upon 1 upon 2. So what will be this? S infinity is 2 under root 2 minus. Example A. What is the sum of first 5 terms of a GP whose first term is term 2 and common ratio is 2, also 2. Okay. What is the solution? So we have to find the sum of first 5 terms whose first term is 2 and common ratio is also 2. What is the S5? N is 5. So Sn is equal to Sn formula is A 1 minus R to the power n 1 minus R. So S5 is A 2 1 minus 2 to the power 5 upon 1 minus 2. S5 is equal to 2 to the power 5 means 32 minus 1. 2 into minus 31 about minus 1. So minus minus will be cancelled out. So S5 is 62. That is fine. Okay. So today's lecture up to this. In this lecture we have studied how to find first and how to find sum of terms of GP. Sometimes it will be asked to find first and terms sum of first and terms of GP. Sometimes finite GP will be given and last term is given. We have common ratio and first term is known. We have to find the sum. Okay, all the terms. Sometimes in finite GP will given. It will ask to find the sum of all the terms. But this is we can find the sum in this case once your common ratio is still less than modulus value of common ratio is still less than 1. Okay, then we can find SNCP. So today's lecture up to this. If you have any problem related to this lecture, you can comment me on my YouTube channel. Thank you very much for today's lecture. Thank you very much. We will see you in next lecture. Thank you very much. Like, share, comment, and subscribe my YouTube channel. Okay. So thank you very much.